Hi everyone, my name is Nicolas. I recently joined Rivian, but I used to work on ConstraintLayout and MotionLayout at Google for quite a bit of time.
Hi, I'm John Hoford. I work at Google. I work on ConstraintLayout and MotionLayout, and I lead the project. So.
All right, before we go into what's going on with ConstraintLayout and Compose, I just wanted to do a quick recap of where we came from with ConstraintLayout. So ConstraintLayout 1.0, we introduced that 2016, so it's been a while, but essentially it's a view group in layout your widgets and has this concept of a constraint set to encapsulate all the different rules. So it's a flexible layout manager. You position stuff relative to one another, which is an important distinction compared to things like rows and columns, and support a ton of other stuff with dimension ratio, etc. The important thing that we introduced as well is this concept of helpers, so that other elements that you can introduce into your layout to help you, but those elements are not automatically widgets. And we brought ConstraintLayout 2.0 that adds the biggest chunk was MotionLayout, plus a few additional stuff around the helpers and stuff like that. So MotionLayout is essentially taking what we can do with the layout in ConstraintLayout, but supporting multiple states and supporting interpolating between those different UI states. And similarly to what we had done for ConstraintLayout with a layout editor, a visual layout editor in Android Studio, we added a motion editor in Android Studio as well. And more stuff that we had in 2.0 with virtual helpers, virtual layout, etc. So then came 2.1 that we just shipped the final version in end of July with a few additions in the constraint properties to essentially program things a little in a nicer way. And a few additions as well in MotionLayout. So let's talk a little bit about that. We added like several virtual layouts like circular flow to that's a helper to lay out your elements in a circle, as the name indicates. Oh, don't go too fast, John. Can you go back on the slide? Thank you. Oh, the next one, sorry. Yeah. All right. And Reactive Guides is a very interesting one that essentially allow you to react to change in the overall dimension of the root layout, and we'll see how that can be useful. We also added more supports in the actual constraints engine to support things like negative marginal, etc. So the Reactive Guide stuff is actually pretty cool because it allows you to support in a relatively simple way things like foldable. So here I'm demonstrating that with the emulator that we ship in Android Studio, but of course it works on the device. And by dropping a Reactive Guide into your layout, you can simply position, create the element position around that, and so you can easily come up with a UI that will adapt. And there is like a developer.android.com webpage that you can go to see how it's done. It's pretty straightforward. The other thing I mentioned was some modification in the way we treat margin and baseline. We finally can do a constraint between a margin and something else, a baseline, sorry, and something else that is not a baseline, so top or bottom. And the other one that a lot of people were asking for was supporting negative margin. So before you had to do this trick with using like a space view or something like that. No, you can just directly set a negative margin.
So ConstraintLayout 2.1, in MotionLayout part of it, we added a lot of things. The whole idea was to try and fill it out and make it a sort of very full featured. And I'll just show a few highlights of that stuff. One of the things we added was a lot of rotation support. So being able to define constraint sets that rotate your phone, that when your phone is being rotated, being able to have polar coordinates of things. Another thing we added is what we call view transitions, which is like the bigger transitions of MotionLayout, except only operating on a single view at a time. And it's a very powerful feature for producing like little effects, like the button click effects you're seeing here being produced by that view transition. Another thing that was kind of a requested feature is the ability to have swipe-based springs. So when you let go, they don't just hit, but they bounce, and various kinds of bounces. The motions can also be quantized, so that if you wanted to achieve like a clicking clock or a any kind of motion that is non-smoothly uniform, you can define it and design it. A big additional feature in this was the motion label, which allowed you to produce kind of rich, wide variety of effects.
So another example of helpers, and just kind of to illustrate also how helpers can be really handy to set up your elements. So if you look at this animation on the right, I'm just toggling between two states, right? Where I'm just moving those tiles in different position, and it looks super messy, right? This is clearly not the type of motion that you would like to have in your application, and it's a relatively common pattern when you just have those two states, things are moving across. So motion helper allow you to apply a specific effect given the direction of the overall direction of the movement, and the default effect is just a fade in, fade out. And so you can, by simply setting that, you say, well, elements that are going that way will just apply this element. And just by dropping that motion effect helper in your layout, suddenly you have something a lot more sleek. But what's really cool is that you can actually use the view transition that John just mentioned and actually specify all kind of transformations like that would apply with those same rules. So here, those transition go something a little crazier with rotation and fade out, and applies with the same rules of identifying the overall direction of movement. So that's a very handy little helper. The other one we added is carousel. So if you want to create this type of very fancy carousel effect in your application, you can just implement that relatively easily with that carousel helper. And again, there is a developer.com web page for that.
So one of the things I just wanted to take a few seconds to talk about, this is the calculator in Material U. And as an example of where motion layout in its with legacy views can generate quite complex, full-featured applications. So calculator has about 11 different constraint sets with lots of transitions and button effects and things, all within basically a motion layout UI.
So if we go back to where we are, essentially we've got this ConstraintLayout 2.1 with all those different complex blocks and etc. So what does that mean for Compose? And essentially we throw away a lot of stuff, but we do keep that core engine that is in charge of interpolating between the different states, setting up the layout and etc. So in fact, the ConstraintLayout Compose and the ConstraintLayout view share the same core engine. So all the functionalities that you have at term will be available in Compose. And for the first version of ConstraintLayout in Compose that we are just releasing, we just released the beta and end of July as well. We have already a really good set, but this is just the 1.0, right? So the main stuff, one second. The main stuff that we have in that version is we keep the common core. We added a DSL in Kotlin so that you can specify the different constraints in Kotlin. And we also did something interesting that we'll cover a little more in that presentation, which is essentially specifying those constraints, the different states, etc., using JSON. And all of that is work in progress. We definitely want to hear from you because we have a really good first set of features for that 1.0, but I think there is a lot of opportunities, and we'll react to feedback. So why, after all, do we want ConstraintLayout in Compose? Isn't Compose coming up with all those much better way of doing UI? And yes, but this is more about supporting the state of your application. In terms of layout, Compose fix a lot of the problems that we have with linear layout. but it still by default lets you specify stuff in rows and columns, a little bit like what you were doing with linear layout. And so in the same way that on Android with the view system, we had relative layout and then constraint layout. For the same circumstances, you could use constraint layout in Compose. So anything where it's easier to be expressed in terms of relative positioning, well, it's really, really handy. Obviously, one other aspect is if you do know constraint layout and you are really comfortable about expressing your UI rules and how the UI is going to adapt to different layouts, and you want to bring that to Compose, well, constraint layout and Compose provide that as well. And finally, because we've got this concept that I briefly mentioned about extracting the different rules for the layout into a constraint set object, and that's essentially what underpins all of the motion layout stuff. That also provides you a really nice way to abstracting how your UI can be laid out in a separate object like that, so that there's this kind of notion of separation of concern. So here is an example with the DSL. And so you notice the different composable buttons and text. And you'll see that on the preview of Android Studio, we do show you not only the composable where they are laid out, but also we visualize the different constraints. And the constraints themselves are expressed as a Kotlin DSL. And you see that it's simply set as a modifier, like a lot of the layout stuff works in Compose. And that modifier is just constraint as, and you pass a lambda, and that lambda allow you to write the DSL. And so you got all the advantages of a Kotlin DSL. You got code completion, static checking, and stuff like that. The other thing that we support is those helpers objects that, for various technical reasons, on the Android view system, actually ended up being views or empty views. Here we don't need to resort to that, and we can simply have them as additional helpers that are not composable. They are just helper to help you create your layout. And here where I'm just setting up a guideline, and you notice that I can reference that guideline in the rest of the constraints. So that's when we want to use the constraint as direct modifiers. But you can also extract all of that into a constraint set object. And that's the one you see on top. And it's the same DSL, actually, but instead you create references for the different elements, a little bit like what you were doing on the Android view system with IDs. So once those references are created, you can just apply the DSL as well. And obviously here in that example, I'm showing all the constraints and the constraint set itself being declared inline, so it doesn't feel that different from the previous example. But obviously that means that you can create different type of constraint set and pass them as needed. You can declare it somewhere else, just pass it to the function. So it gives you quite a lot of flexibility on how you want to specify the layout. And that's what I meant by separation of concern, right? You could essentially create a version of that composable where you only care about the composable, which composable should be on screen, what they should look like, what states do they need to respond to, and etc. And how they actually laid out can be defined somewhere else. Now, I mentioned the JSON syntax to specify those constraints, and that's an example of this. Notice it's actually exactly the same example. You see it on the right, it shows the exact same thing, but this time it's in JSON, or more exactly JSON5, which is a nice superset of JSON that makes it a little easier to read. And we have support for that in Android Studio. You see the color syntax highlighting, and it's just a string actually. So here as well, it's as far as the rest of the system is concerned, it's just a constraint set that we initialize from a string. But obviously that also brings a lot more interesting flexibility on how you could actually pass constraints, because you can represent them as just a random string. The other thing that is really handy is we have this thing in Android Studio that's called live literals, where we identify literals like numbers and things like that. And if you only modify that, we can update the preview in Android Studio very quickly. It also works on device, by the way. So if you have a device connected to Studio, it also works. Now, because this is just a string is a literal. So that means that any modification can react instantly as well. And contrary to the normal live literals, here anything is fair game. So if I want to add a constraint, it still will reflect instantly in the preview. So that can provide a much tighter feedback loop when you are playing with UI. The other thing that we support in that constraint layout compose is automatic animation when you do change the constraint set. So if we look at it a little closer, I'm defining two constraint set, and actually you notice here that I'm just defining two strings. The actual constraint set are initialized just below at the bottom of the string, and so I have a constraint for a box, and that box has a different dimension depending on the constraint set and a different position, and we even apply a rotation. So how do we deal with that? We just decide to pass the constraint, one of the two constraint sets, CS1 or CS2, depending on this flag animate to end. And we just pass it to the constraint layout, and we just need to set this animate change is equal true to the constraint layout composable. And so if we zoom out and we look at the overall experience that you get is that when I click on the button, the flag changes and we animate the change of constraint set. So that provides you a very easy way to toggle different layouts or different animation like that are specific to layout. And notice, like, I just needed to define those two constraint set for the start and end of the animation. So looking a little closer, how is it all implemented? Well, essentially, when that flag is true, we get the constraints and we pass that to MotionLayout. And because yes, we do have an implementation of MotionLayout in Compose.
So that brings us to a little bit about MotionLayout. One of the things that's a little bit unique for this release of MotionLayout is that we're heavily invested in the JSON syntax. And so to really use MotionLayout now, you need to use the JSON syntax. It also has a limited feature set. So you just get constraint sets, transitions, key position, key attributes, key cycles. So we're missing a few things. We have lots of examples, and you'll see more about that later. But first, I wanted to just take you through a very basic example. Here you have a composable. It consists of a column, a motion layout, and a button. And in the motion layout, you have 3 boxes, and the animation is done with an animate to end variable in a remember, and you see the button click just toggles the animate to end, animate to beginning. So that it's a fairly simple setup. But what we want to look at in this case is the progress is being pushed into motion layout. So motion layout is being driven by the progress. And the motion scene is defined as a string, and I have it collapsed here. So let's go in and expand that and see what's inside of it. It's a header, which is just for simple use, constraint set, and a transition. If you look inside of the constraint sets, you will see that it consists of the 3 constraints, 1 for each ID for each button, ID1, ID2, and ID3. And the other constraint set, the ending constraint set, is actually there. I just collapsed them because we don't need to see the same thing twice. And one of the nice things to look at is you can collapse them really nicely. Transitions, they point to the base is pointing to the start, points to start, and end points to end. So that's how it all ties together, the transition that you're trying to run. And inside of these keyframes are the key positions and key attributes. And we'll get into those a little bit more later. Here's the key attributes, and the IDs are mapped into this. Again, this is the ID for which the key attribute is going to be applied. So let's actually go ahead and take a look at what happens when you modified some of these things when you run this thing. So what I will do is hit play, and that starts interactive mode on the IDE. And now you can see those three widgets moving around in various patterns. And it's actually completely interactive within interactive mode. So in general, you can use that as a way to test your system, or you can hit play and it will push a version of your application into the a device that you set up, and the device, and it works just the same way. So we don't have to actually show it twice. Now, interestingly, there's a debug flag you can set. So I had it commented out before, so let me uncomment it. And when you uncomment it, you'll have to do a build. Just hold on for a second. Okay, uncomment it. And then we do a build. And this is recorded in real time. So this is how long it takes. Now, when the debug flag is set with show all, it can actually show you the paths everything will move on. And so by notice you can click on the buttons and stuff to see where they are. But let's go back into interactive mode, hit play, and you can see that the paths are all predefined. It's all being designed for you. It's well prescribed. Now that we can see the paths, let's show that we can change the paths using the live literals concept, changing the %y. We'll add a value, and as we change the value, notice the curves change in real time as you change them. And it's live, you can play it. So it takes about 0.3 of a second or 0.4 of a second for it to update. It's very, very quick, but here in this case, things are moving in an arc. If I commented out the arc mode, you see it now moves in just splines, the default. And notice that the JSON syntax, even though it's a string, the IDE provides a lots of utility in there. I can collapse and open sections. I can move things. I could comment out things. So it's a string, but it actually can edit almost the same. You can also put the JSON string in a separate system. One more thing about these key cycles or key attributes. Notice that how compact it is. You can specify 4 key cycles in this case in one small section of code. And it maps such that each of the columns represents a different key. And if you express that in the legacy view, you'll see that it's extremely big. Here's a couple of just examples that we have in our system, showing that you can build relatively complex, meaningful applications associated with MotionLayout. And for a lot more examples and a lot more of that kind of just viewable things, you can go to our website. And in the website, if you scroll down, you'll see a whole bunch of examples. And if you click on the composable, it'll take you to the link where you see the code that did that particular example. Okay.
All right, so hopefully that gives you like a good idea on the different advantages of the Decision5 syntax. So it is a new syntax to learn, but on the flip side, it's a lot more succinct than XML. It's definitely easier to parse, it feels to me. But the other advantage is that we end up being in full control on what we want to put into that syntax, right? Which means that we can actually create new ways of representing things that we did not have the flexibility, not quite with the XML stuff, just the way the XML parser was implemented on Android. It also opens some interesting doors about cross platforms, some tooling, opportunities like you saw with live detail roles, and again, like the separation of concern idea, where you could imagine in your code focusing on the actual logic and the behavior, but extracting the way things look or behave, visually to something else. And there is more stuff coming. So just a quick example when I mentioned interesting syntax. We created these two concepts, like the variables and generate, that let you specify this type of complex behavior really easily. So let me walk you through it quickly. Here in that example, on the compose side of things, I'm not showing, but on the compose side, it's literally just a for loop, putting a bunch of colored boxes. And I tag them with the tag box. So if you notice here, I have this my list, which is in the variable section, and I say, hey, my list, initialize yourself with the list of boxes that have that tag box. And in the generate, I say for all the elements in my list, let's apply those constraints. And I'm just listing the different constraints. Now there is this added twist. You notice that, let's look at, for example, circular. Circular is a circular constraint connected to the parent with an angle and the distance. And angle and distance are just variables that we define in the top block. But notice how they are defined. We have some variables like distance that are just straight values, but we also have variables like angle and rotation that are generators, where essentially every time we call or we reference those variables, a different value will come according to the rule set into the block. So every time angle is called, it will increment by 10. Same for rotation. And there is some opportunity as well to set up override variables when you set the constraint set on the MotionLayout or ConstraintLayout. So that becomes like a very easy way to have something is not as dangerous, let's say, or complicated as some of the other solutions, but at the same time still providing this level of customization you might be interested in. The other thing that I want to touch a bit upon today, it's what we could do around tooling. And John showed you like a lot of what can be done right now, today on Android Studio. But we've been exploring something called, and we put that under something called Link. It's an application that you can actually go and grab from the ConstraintLayout GitHub. And I think it's a very interesting concept that I think, a lot of those ideas that we're exploring via Link, we hope to bring to Android Studio. But right now, Link is more like a little playground, right? To see what we can do. So what can it do? The basic idea is that it's an application you run on your desktop that connects to a live Android application that you developed and connect through NEDB tunnel, right? And there is some instructions on the GitHub on how to set that up. So how does it look like? So you have to run your application. Somewhere in your code, you need to add this link server.kotlin. We'll probably move that to a utility library at some point. And you just set an NEDB tunnel between your machine and that. And in that example, we are using the simulator, but obviously that would also work with a real device that would be connected to your computer. So we start with this. We open the Link application. And one thing we can already do from the get-go is to pull the JSON5 on the live application. Then we can actually have a visual inspector. And notice how it tracks completely frame by frame what's happening on the device, providing a lot of additional debugging information. But we can also do more in that visual inspector. You can select, you can have an inspector to see how the values are evolving over time. And because we wrote Motion Editor, we can reuse the timeline from the Android Studio Motion Editor, showing you even more context and seeing how the values evolve. It's an actual timeline. So not only can I play with the application on the phone, which is super useful when you want to see how the application behaves. You can also drive that animation from the timeline and go at any point in time, seeing how things go. The next thing is that JSON string that we pulled from the device, we can actually modify it into the editor, and the modifications are going to be applied in real time straight on the device. So another interesting stuff that we've been toying with is this is all great when you have everything's already set up and you want to inspect. But we also support creation. So here I just added a button onto that empty screen, and I'm applying constraint. Notice that I'm also I also support some kind of editing, where I can essentially we could re-implement all of the existing layout editor within that model. And here notice that I'm changing the string of that button, and it all updates real time. So one just to describe a little more this approach, we've noticed that in the JSON, it's a little small, but it's in a design section. And you see here that I'm just creating a button with the type button with the text. This mapping between what you describe into that section is actually something you can override into your own application. So by default, we do support a few basic things, text, button, stuff like that. But you can actually create your own library of composable that would be mapped to something in the design section. So one really nice thing is that example. Here, I'm just adding an image, and it works. What's really cool is that that image has been added as a custom interpretation using the coil library. So it loads the image from the network for you. And similarly, I can still go and apply and build up all the different constraints and behavior. So I want to stress that that is actually not possible to do within the context of the Android Studio preview, because in the Android Studio preview, we do forbid network connections. While here, because we are taking kind of an upside down approach, we are just a kind of very powerful inspector. As long as you have a running application, we can do it. So you don't have to deal with fake data or sample data. You can just literally use your application as it's meant to be used. So it essentially cut down a lot of your work while retaining a lot of the editing capabilities we normally have in Studio. The other thing that is interesting is that we can actually simulate the device sizes. So you can very easily test how your layout is going to react to different device sizes and etc. And we do that by essentially scaling that root element. So you can still use your emulator or your real device as a canvas, essentially. And you can notice here that I didn't like the way it was behaving, so I'm modifying the behavior of the image. Now it's actually correctly resized within the bounds, but I'm looking at the button. It's not where it should be. So I can just add a new constraint in button so that it will be correctly positioned underneath the image. And again, notice that all of that is live. All of that is instantly reacting to your stuff. So it really reduces that edit cycle, and we think it's going to make overall playing with UI a lot more fun. And you notice how you can quickly test that those constraints behave correctly with different device sizes. So just to recap of where we are right now. So we did release the 2.1 final in end of July, and the first beta of the ConstraintLayout Compose same time. And personally, I also happen to have left Google to join Rivian. So working on UI. In fact, we are hiring. If you're interested to work on electric vehicle and interesting UI work there, please contact me. But I leave ConstraintLayout in really good hands with John. And in fact, we just released the new version.
Yes. So yes, we released last week 2.1.1 of the constraint layout. So the 2.1 or 2.x line of constraint layout. And we also released ConstraintLayout Compose RC01, which means we are trying to stabilize and release this first version of ConstraintLayout for Compose. It doesn't mean we stop work when it hits 1.0. As soon as 1.0 is out the door, you will start to see a 1.1 alpha, and we'll go through a full alpha beta cycle. Hopefully out near the end of the year, we'll achieve some sort of feature parity with the 2.1 line of things. Give us feedback. We're very active on GitHub in ConstraintLayout in GitHub. And you can also file bugs at Google Issues. We are also on Stack Overflow and anywhere else that you'll typically find us. Okay, and thank you. John Hoford at Google and Nicolas.
And I think we have a few minutes for a few questions. So the first question I'm reading on the chat was, what is the timeline for fully supporting Kotlin DSL in MotionLayout? Is prioritizing JSON just a fast development decision? I'll let John answer.
Good question. Good question. It's somewhat intentional. We want to flush out, emphasize, get feedback on MotionLayout, and since we're not even really done with MotionLayout in Compose, in terms of we're missing quite a lot of features, we decided to prioritize getting the JSON up and running, and anybody who's desperate to use MotionLayout in Compose will have to put up with the JSON syntax for now. We do plan to put out the DSL, but only after we are stable in the JSON, and understand that both the DSL and the JSON do pretty much the same thing. The JSON is interpreted by an interpreter, and it writes out the binary structures that the internal engines use. The Compose DSL will just write out this binary data structure as well. So we don't anticipate to be a big performance hit if you use the JSON. But probably by the end of the year or soon after, we will have the DSL. Any questions?
So from the Slack, when should we use MotionLayout versus the animation composable? Does MotionLayout compete with animation for doing animation in Compose?
Good question. Very good question. I would say it's almost as the same as before. If you're doing something very simple, just use the underlying Compose animation APIs. It's a very rich, powerful API set. We like it. It's very good at things like, oh, here's a button that I need to make disappear. That's like trivial in Compose. If you're doing something more complex and coordinated, it might get tricky. And it becomes one of two tools in your toolbox, right? You use a kind of a more primitive, lower level APIs that then you compose them so the way Compose works, or you can use something higher level which assembles across things. It's also important if you're coming from legacy and you're coming from building some UI in MotionLayout in legacy views, and you're going to migrate to Compose, you're not under this, well, I don't know how to build all of this stuff that I built in MotionLayout in Compose. You have MotionLayout in Compose to build it. Does that hopefully help make sense?